Hello and welcome to this brand new video. In this video, we'll be looking at standard form and approximation. So you start with standard form. When we say standard form, what exactly do we mean? It is when a number is written in the form a times 10 raised to power n, where a is greater than 1 but less than 10. Is greater than 1 but less than 10. While n is an integer. It could be positive, it could be negative. Now, that's basically what standard form is. When a number is written in the form a times 10 raised to power n, where n is greater than 1 but less than 10, and n is a positive or negative integer, then we say that that number is in standard form. When it now comes to conversion of numbers from standard form to full form or from full form to standard form, there are some concepts that you need to understand. First thing is that any number written has a decimal point. Either it is implicit or explicit. That's the first concept that I want you to know. Concept 1. Any number written has a decimal point. Implicit or explicit. For example, if we have 450 is a number, we have 6.80 is a number. In this case, 450, there is an implicit decimal here, point, full stops, right? Here we have an explicit decimal, 6.80. So when a number is written without an explicit or an obvious decimal point, just assume that the decimal point is at the final, after the final digit. So this concept will help you when we start solving some questions in number base. And then concept 2. Concept 2 is that, we have established that number base is written in this form, right? So for us to get this n integer, we say it can be positive or negative. How do we know when it's positive? How do we know when it's negative? Basically, this is the idea. If you are moving the point in the number towards the left, n would be positive. If you are moving the point towards the right, then n is negative. And I would explain as well with this example up here. We have 450. This is a full number. We want to write it in standard form. We have established that there is an implicit decimal here, right? So what is standard form? That the number, want to move the number such that it is just in front of the first digit. The first digit here is 4. So we want to move this point from here to the first digit. So that means we are moving towards right or left. Exactly, we are moving towards the left hand side. So we will move 1, 2. So it took us 2 steps to get to the in front of the first digit. We counted 2, right? So that means n is, because we move towards the left, it will be what? Positive. So we can write this as 4.50 times 10 raised to power positive. How many do we count? 1, 2, positive 2. So 450 can be written as 4.5 times 10 raised to power plus 2. And if we look at the other example, in terms of 6.80, you would see here that the point is already in front of the first digit, so we don't need to move it. It's already in standard form. So this is as saying 6.8 times 10 raised to power 0, and when we did number base that anything raised to power 0 is 1. So 6.8 times 1 is still 6.8. But what if we have a question like 0.00579? You see that the decimal point in this case is here, and we want to move it to the front of the first non-zero digit. The first non-zero digit here is 5. So if you want to move it, we will be moving towards the right hand side. 1, 2, 3 times. So n is negative because we were moving towards the right. So this becomes 5.79 times 10 raised to power minus 3. If you understand this concept, you have asked the standard form as a topic. The final concept that I mentioned while I was explaining the examples, to put it into context, the final concept is that you have to move, for a number to be in standard form, move the points, explicit or implicit, to the front of the first non-zero digit in the number. So, and you see that that was what we did here. The first digit here is 4. So we moved this decimal point to 4. The first digit, non-zero digit here is 5. So we move the point to front of 5. And so that is the whole idea of working in standard form. Let's take some examples. So let's start solving from the first example. 1a 23. This does not have an explicit decimal point. So we assume that it has an implicit one, and the first non-zero digit here is 2. So we intend to move this to 2. We move only once to get there. Since we are moving towards the left, n is positive. We move 1, so that's plus 1. So this becomes 2.3 times 10 raised to power 1. Question B. 146200. There's no explicit point. We assume there's an implicit point after the last digit. So we want to move that point to the first, in front of the first digit. So we start counting, moving towards the left. 1, 2, 3, 4, 5. So because we were moving towards the left, this is positive. We counted how many? 1, 2, 3, 4, 5. So that's positive 5. So we write this as 1. Remember, we have bring the point here, 0.462. So also, zeros after decimal point is negligible, so you might choose not to write it. So times 10 raised to power what? 5. And that's our answer. 758. There is no explicit decimal point. We assume you have an implicit decimal point at the back of the last digit, and we want to move it to the front of the first digit. So we move 1, 2. Because we are moving towards left, our n is positive. We move twice, so n is plus 2. This becomes 7.58 times 10 raised to power 2. 0.00469. We have an explicit decimal here. We want to move it to the front of the first non-zero digit, which is 4. So we start moving, we move towards right. 1, 2, 3. So this becomes 4.69 times 10 raised to power minus 3. Minus because we're moving towards the right, so it's negative, and we moved 3 times, so that's why it's minus. And question E, 0.00513. We have an explicit decimal point, so we want to move it to front of the first non-zero digit, which is 5. So we move it 1, 2, 3. So this becomes 5.13 times 10 raised to power minus 3. Minus because we are moving towards the right, and 3 because we moved 3 times. You are asked to write the numbers in full. 6 times 10 raised to power 0. Note that 10 raised to power 0, that means we are not moving at all. So that's still 6. Or if you want to use the knowledge from number base, 10 raised to power 0 is 1. 1 times 6 is still 6. So for question B, 1.52 times 10 raised to power 3. There are two ways to go about this. Either you say 1.52 times 10 raised to power 3 is 1000, right? So, and just use your calculator to do 1.52 times 1000, and that will give us 1520. That's method 1. Method 2 is 1.52 times 10 raised to power 3. This 3 means that it's positive 3. So what does that mean? Now we say positive means that we are moving towards the left for us to get a positive. So that means we will do the reverse of it. For them to get positive 3, they moved from the right hand side towards the left. So for us to write this in full, we move from this towards the right. So this will become 3 times. This is 1.52. So we will move it the points 1, 2, 3. So since there is no digit here, we had 0. So the point will now be here now, and it will be 1520. 1.32 times 10 raised to the power minus 5. You can either say 1.32, because it's minus 5, they move towards the right. So we have to move towards the left. So either you say 1.32 times 10 raised to the power minus 5 will give us 0.1234, 0.00001, and that will be 0.1234. Here they are moving from left to right, so we'll do the reverse by moving like this. So we want to move like this in 5 ways. That's the second method. So 1, 2, 3, 4, 5. So the new point will now be here. So write 0, 0, 0, 0. So and that's how we get that. Our answer will now be 0.123412. And final question, question 3, 9.721 times 10 from minus 1. So the shortcut to this, because it can be quite confusing, this is just, if it's negative and you want to change it to full, so that is negative 8. So just add 7 zeros. With this 9 that will make the 8. If it's minus 6, how many zeros will you add in front? You add 5 zeros. If it's minus 4, how many zeros will you add in front? 3 zeros. So this one minus 8, we add 7 zeros. So it becomes 0.123456 7. Then we add the number 972. So you see that if you are counting like this, 1, 2, 3, 4, 5, 6, 8 is correct. So this is that on standard form. Let's take the take home for this standard form concept, and in the next video we'll look at approximation. So take home question 1, express A 0.0462 in the standard form, B 0.000215 in standard form, C 1587 in standard form. So I'll see you in the next video. Remember, if it didn't make sense the first time, watch it again. That is the MathSense.